In the second session of the ongoing series, Important Points to Study for Plus 1 Chemistry examination, I will discuss 4 chapters. Chapter 5, States of Matter, Chapter 6, Thermodynamics, Chapter 7, Equilibrium, and Chapter 8, Redox reactions. Chapter 5 is States of Matter, types of intermolecular forces and their characteristics. How temperature is affecting these intermolecular forces. What are the characteristics of a gaseous phase? 4 different gas laws such as Boyle's law, Charles' law, Gay-Lussac's law, and Avogadro law. You can expect numericals related to these gas laws. Very, very important portion. How to derive ideal gas equation and equation of state or combined gas laws. In most of the years, at least one question is being asked on numericals associated with ideal gas equation or combined gas laws. Similarly, Dalton's law of partial pressures and numericals associated with this law frequently asked in exam. Definition and formation of aqueous tension and partial pressure. They are also very, very important topics. One of the most important topic in this chapter in examination point of view is the postlates of kinetic molecular theory of gases. You should know not only the postlates but also the behavior of particles in gaseous phase. Reasons behind the deviation from ideal gas behavior of gases and listing the conditions when gases deviates from its ideal behavior. Ideal gas equation and its interpretation, boil point, compressibility factor are also very, very important topics related to gaseous phase. In the topic liquid state, you should know the terminology and definition of vapor pressure, boiling point, critical temperature, and viscosity. Reasons behind variations in the boiling point at different conditions, such as at high altitude, were asked several times in exams. Similarly, definition and reasons behind surface tension of liquid, factors affecting surface tension of a liquid, and how the surface tension leads to capillary action of a liquid are also very, very important topics in this chapter. Questions came in previous examinations under this chapter are listed here. The questions involve the properties which gives the physical state and behavior of matter as well as the factors affecting the properties of a matter. Question number 1 is an example for it. Repeatedly, questions were asked on ideal gas behavior of gases and the reasons behind the deviations from ideal gas behavior. Postulates of kinetic molecular theory of gases were asked in several examinations. Questions related to gas behavior such as boil point, compressibility, and critical temperature were also being asked. Numericals related to ideal and real gases, gas laws such as Boyle's laws, Gay-Lussac's laws, Charles' laws were repeatedly came in examinations. Viscosity of liquids, effects of different factors on viscosity of liquids were also asked in different examinations. Thermodynamics. In this chapter, you have to describe the terms related to thermodynamics and their physical meaning. Terms such as system and surrounding, types of systems such as open, closed, and isolated systems with examples have been asked frequently in examinations. You should be able to differentiate state functions and path functions. You should be able to identify state functions and path functions and write the reasons why they are called state and path functions. Next topic is internal energy as a state function. You should be able to represent the relationship between internal energy with the work and heat with the help of an equation. How the internal energy of a system change based on work and heat. Meaning of work in thermodynamics is the next topic in thermodynamics. You should be able to differentiate reversible and irreversible processes with the help of examples. Free expansion in the work point of view should be described with the help of an example. Meaning and equation on isothermal and free expansion of gas is also a subtopic under this main topic. Enthalpy is the next topic. Definition and equations related to enthalpy. Differentiate endothermic and exothermic processes based on the enthalpy change. Numericals related to conversion between internal energy and enthalpy is also another very important topic. You should be able to differentiate extensive and intensive properties. Derive a relationship between the heat capacities Cp and Cv and the numericals associated with this relationship. Why Cp is greater than Cv is also an interesting question. Measurement of enthalpy and internal energy change using calorimetry is the next topic. How this measurement can be done with the help of a bomb calorimeter and numericals related to calorific value. How the enthalpy changes in chemical reactions and phase transformation. Hess's law of constant heat summation and its uses is another important topic in this chapter. You should be able to describe the terms related to enthalpy such as ionization enthalpy, enthalpy of combustion, enthalpy of atomization, enthalpy of solution, enthalpy of dilution, lattice enthalpy, and you should be able to construct a Born-Haber cycle. You should be able to draw an enthalpy diagram for lattice enthalpy of sodium chloride as an example. Spontaneity in a reaction and its relationship with entropy and an equation to express that relationship is also very important. Numericals related to Gibbs free energy and entropy, second and third law of thermodynamics and their significance is also an important topic. An equation to represent the relationship between equilibrium constant and Gibbs free energy and numericals using this equation is also important. Previous year questions. Questions from previous examination in this chapter are given below. Questions are from Hess's law, question number 1. Systems and surroundings, question number 2. Differentiate extensive and intensive properties. Differentiate state and path functions. Definition of lattice enthalpy, entropy, and drawing of Born-Haber cycle of NaCl. Frequently these questions came in examinations. Numericals related to isothermal expansion, first, second, and third law of thermodynamics are also repeated in examinations. Next chapter is equilibrium, which is relatively a bigger chapter. Meaning of the term equilibrium and why chemical equilibrium is considered as dynamic, not static, is the first topic. Next topic is physical processes. Discuss about solid-liquid equilibrium and explanation to melting and freezing points. Similarly, liquid-vapor equilibrium and explanation to boiling point. Effect of vapor pressure on boiling point of a liquid is another important topic, and related to this, questions such as how the environment affect the boiling point and the concept of sublimation using solid vapor equilibrium. Next topic is equilibrium involving dissolution of solid or gases in liquids. How the dynamic equilibrium exists between the solute molecule in the solid state and in the solution. Define Henry's law and how Henry's law can be used to explain the solubility of gases in a liquid at different conditions. And general characteristics of equilibria involving physical processes is also an important topic. Next topic is equilibrium in chemical processes, dynamic equilibrium. Draw a graph which represents attaining chemical equilibrium and its explanation. Explain the concept of chemical equilibrium using the reaction which leads to the formation of ammonia and formation of hydrogen iodide. These two questions repeated several times in previous year question papers. Next topic is law of chemical equilibrium and equilibrium constant. In this topic, one should learn definition of law of chemical equilibrium and its representation using an equation. How to represent equilibrium constant both for in solution form and in gaseous phase. Numericals related to calculation of equilibrium constant and units of equilibrium constant are other two important points. Applications such as how to predict extent of reaction, how to predict direction of a reversible reaction, and calculate the equilibrium concentration are also important. Next topic is the relationship between equilibrium constant, reaction quotient, and Gibbs free energy, and numericals related to their relationships. Most important topic in this chapter is Le Chatelier principle, and based on this principle, discuss the effect of temperature, pressure, removal of product from the reaction medium, addition of reactants to the reaction medium. These are very, very important points. Give attention to these reactions related to Le Chatelier principle. The reactions are formation of ammonia from nitrogen and hydrogen, formation of hydrogen iodide from hydrogen and iodine, last contact processes, which is the formation of sulfur trioxide. Next topic is concepts of acids and bases such as Arrhenius concept, Bronsted-Lowry concept, Lewis concept. Students should know how to classify the reagents into acids and bases using these three concepts. Conjugate acids and base concept is the next important topic. You should be able to identify acid, base, conjugate acid, conjugate base in a given reaction. Also, classification of acids and bases into strong and weak, and a relationship between dissociation constant Ka and Kb. Student also should be well versed with the ionic product of water and its significance. Next topic is the reason behind common ion effect with an example. Related to buffer solution, one should know the characteristics of a buffer solution, how to make an acidic and basic buffer solution, as well as its application. Importance of Henderson-Hasselbalch equation and the relationship between dissociation constant of a weak acid related to pH of a solution when it undergoes neutralization. Last topic in this chapter is examples of sparingly soluble salt and their dissolution constant. In the previous years, questions were repeated in the topics such as common ion effect, conjugate acid-base concept, Le Chatelier principle, concepts of acids and bases, and buffer solution. Numericals associated with solubility product, dissociation constant, equilibrium constant, pH of a solution also were repeated several times in the last few years. Next chapter is redox reaction, which is relatively a small chapter. In this chapter, you should know different definitions of oxidation and reduction with respect to addition of or removal of oxygen, hydrogen, electropositive and electronegative elements. Also from the definition, you should know how to identify oxidation and reduction. Most important topic in this chapter is the definition of oxidation, reduction on the basis of acceptance or release of electrons. From a given equation for a reaction, student should be able to identify oxidation, reduction, oxidizing agent and reducing agent by looking at the oxidation state of the atoms. Here one example, sodium reacts with chlorine, forms sodium chloride. You have to identify here which reaction is oxidation, reduction and which reagents are oxidizing agent and reducing agent. One more example, zinc reacts with copper sulfate, forms zinc sulfate and copper. Here also by looking at the oxidation state of the atoms in this equation, you have to identify which reaction is oxidation, which reaction is reduction, which reagents are oxidizing agent and reducing agent. By checking the oxidation state, students should be able to identify whether the given reaction is a redox reaction or not. Here also I have given the same examples. Concept of electrode potential, standard electrode potential, electrochemical series are the next important topics. Competitive electron transfer reaction is the next topic. Under this topic, questions such as can we store zinc sulfate solution in a copper container? Can we store copper sulfate solution in zinc container? Once we dip a copper nail in silver nitrate solution for a long time, the color of the copper nail changes. What is the reason behind it? These kind of questions are repeatedly asked in the previous year question papers. Last topic is how to balance a chemical equation with the help of oxidation state of the atoms using oxidation number method and half reaction method. In the previous year question papers, questions were repeated in the topics of balancing chemical equation, identification of oxidizing agent, reducing agent, oxidation and reduction. Questions related to competitive electron transfer also repeated several times in the previous years.